Hello friends, welcome to Unacademy. Welcome to today's session. In this session, we are going to discuss about the importance of page replacement algorithms and why we are doing page replacement algorithms. Before entering into details, first let us say our anthem together. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Let us say our anthem together. Crack Get Plus subscription and access unlimited live and recorded courses from India's best educators. About myself, Srinivasrao IS, having 17 years of experience in the GATE in the various subjects, also had industry experience as a system analyst and a database admin with a good certification in database side and networking side. Throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students are working as topmost software professionals in good MNCs, as well as they are also acting as GATE mentors. And you also, once you crack GATE examination, you also can be a software professional or also can be a good educator. So use my referral code to get the admission into Unacademy. Once you get the admission, then you're going to see that all the restrictions are going to be cleared and you are eligible to watch all kinds of lectures which are offered by Unacademy portal. Now you also see that once you get the admission, you're going to get unlimited quizzes, unlimited live lectures, n number of recaps, and you can listen the lectures of various good educators. Utilize this opportunity and try to crack your GATE examination by taking a good stuff which is offering from an academy. There are two kinds of subscriptions are available. One is suitable to fourth year students. The other one is suitable to second and third year students. So 12 months is the most fit for fourth year students where you're going to get a good lectures and live tests. Live tests are going to create a lot of impact on your GATE rank. So all fourth year students are eligible to get the referral code and enjoy the 10% off along with the many other redeem points. As far as third year subscription and second year subscription concern, it is for 24 months where you are going to get the many things duration of the 24 months which include many kind of varieties of lectures and live quizzes and live tests too. So utilize my referral code and you're going to get a good discount. Let's crack GATE CSC. Use my referral code to get the admission into Unacademy. Hit the bell icon for the latest notifications and updates and subscribe to our YouTube channel. And one important thing I want to tell you before entering into the discussion that admission. If you are taking admission in Unacademy, then you're going to get many kind of benefits. The benefits are with confidence you can able to attempt interviews, but in interviews they are going to ask very few subjects like C and data structures, database management, system operating system, and computer networks and core Java. So this admission you're going to get all kinds of stuff which are very useful to your interviews. And secondly, it is eligible for any kind of public sector undertakings examination. So if you're able to qualify GATE examination, then you are automatically easily clear your PSUs because many of the PSUs are based on GATE pattern. Apart from that, you're also eligible to write your net examination. This is one another important thing. So one admission will give you various branches. So utilize this opportunity which is given by Unacademy, either 12-month subscription or 24-month subscription. Once you get the admission, you can able to interact with all kinds of faculty members which are there in Unacademy portal. So now let us talk about our session. What is our session? Page replacement algorithms. So first of all, why page replacement algorithm? This is the first important question. Why there is a need of page replacements? This is the first question. So we know This information you are going to get whether the page can be modified, that means what, whether the page can be replaced or not. This all depends upon the concept of a page fault. So that means what, to handle the page, especially to handle the faults which are there in the pages, that can be handled using a concept of what, bringing the page from secondary memory and placing it onto main memory. So what is an idea? So you see that the whenever the CPU is executing a page and which is not available in your main memory, then we are going to call it as that it is a page fault. So whenever page fault is there, then we are going to do the 6-step process. The 6 steps process is nothing but getting the page from your secondary memory and placing the page into your main memory. Therefore, what happened? I am bringing the fault page and I am trying to keep it on main memory. Once you keep it in main memory, then the CPU can able to execute your process successfully, unless and until you get the next page fault. So what is the concept is that why we are going to get the page faults. The reason for page faults that as you are having a very small amount of main memory. So that's why. What is the reason for page fault? This is one of your interview question. The reason for page fault, you see that due to small amount of memory. So when you are having a small amount of main memory, then you are having the concept of what, page faults. That's why better you have a good system which is having a good amount of memory. Therefore, page faults can be reduced. Now our task is that we understand there is a page fault. So how to identify whether there is a page fault or not? Here we learned a phenomena that the CPU is identifying a page but which is not available in your main memory, then we can say that it is a page fault. We guess who is going to give that kind of information. So that's what. Now we need to believe it on page map table. The page map table is going to tell you all kinds of stuff here. Please observe the page map table is having a frame number and present and absent bits. Our concentration is about present and absent bit only. That means what, friends? Whenever you see that a page which the present and absent bit is it is going to decide. If I am saying that this is a present, then you can understand that this page is available in main memory. And the CPU goes to the next page, and I said that there is a page number 2, and if it is unavailable, that means what, it is not available in main memory, then we can understand that it is absent. When there is absent, you are not going to get its main memory location, therefore it is a blank. So when you are having this kind of a situation, by believing in a page map table and a bit called present, absent, valid and invalid bit, you can able to see that this is what is the concept of what, page fault. This is a important point and important bit. Why we are getting the page faults? That's the next question. Why we are getting a page fault? Why we have page faults in real time? Because as we are using the concept of what, demand paging. Because of demand paging, whenever you say that the concept of a demand paging is nothing but the CPU can successfully execute your program one after another even by having a small amount of memory. Therefore, because of a demand paging, there may be a chances of what, page faults. So in order to handle the page faults, we have the concept called page fault service time, and along with that we want to bring that particular page from your secondary memory and place it into main memory and see that your page is going to be hit now. Therefore, you see that there are interlinking to each other. What is interlinking? Because you are using the demand paging concept, therefore there may be a chance of what, page faults. Who is going to tell that there are page faults or not? Your page map table, there is a bit called valid or invalid, or you can also say that present or absent bit. If it is 0, it is unavailable. If it is a 1, then it is available. Now you see, whenever you have a page faults, then immediately need to do a concept called swapping. So what the swapping is going to do? Bring the particular page from your secondary memory, keep it in main memory. So this kind of activity we are doing. There I am performing an option and an operation called swap in also called as a roll-in. What is the meaning of swap-in? We are trying to put the particular page from your secondary memory and try to place it in a main memory. Hence we are doing a concept of what? Swap-in. So up to here it's perfectly alright as we learned in the last session. But now why there is a need of the page replacement algorithm? So come to the point. So need of the page replacement algorithm. The need of the page replacement algorithm is, please observe friends carefully. So please observe carefully. If the page referred by the CPU is not available in main memory, then we understand that it is a page fault. Who is going to tell you? In page map table, you see that valid and invalid bit is becomes what? Valid. Or you can say 0. Then the requested page is not found, we know. And now you see what to do. We are going to perform a swap in using two concepts. One is that what? Frame allocation. The other one is what? Page replacement. There are two methods we are using whenever you find a concept of a page faults. So in order to handle the page faults, there are two mechanisms are there. One is a frame allocation, the other one a page replacement. So what is a frame allocation? This is the frame allocation is applicable only when you are having a free slots in your memory, and page replacement is done when you are not having any free memory slots on your memory. So two different things. One is a what? There are some free slots on your memory, and one is one there are no free slots on your main memory. If I am saying that frame allocation mechanism is such that allocate the required frames whenever there are some page faults occurred. So how to allocate that? Bring your particular requested pages from secondary memory and perform a swap in or roll in operation that are going to be placed onto your main memory. Now you understand carefully. This mechanism is only applicable only when there are free slots on your main memory. That you don't forget. The frame allocation mechanism only done when there are free slots available in main memory. Otherwise, you cannot go for frame allocation mechanism. Simply what I am doing, I am trying to bring the page from your secondary memory, and I will see that before performing a swap in operation. I am doing a swap in operation here. Before you are doing a swap in operation, you need to see that are there any kind of empty slots are available or not in your main memory. If there are empty slots are available in main memory, then there is no concept of page replacement here. Just we are trying to put the frame on a particular available idle slot or empty slot. Therefore, friends, the frame allocation mechanism we use directly without using any concept of replacing whenever there are some kind of blank slots are available in your main memory. That means what? Your secondary memory, before performing a swap in operation, it needs to check that are there any idle slots or not. If there are idle slots, immediately place it. If there are no idle slots, then come to page replacement concept. Please understand this page replacement concept we do whenever there are no free slots on your main memory. Now you observe carefully. The page replacement algorithms needed whenever there are no memory slots are available in your main memory. So now in this case what is going to happen? The secondary memory is try to place your particular requested page on your memory using a swap in operation. So this is your memory. See that your memory is a completely is been occupied by different kinds of frame slots earlier. Therefore, now I cannot able to place using a frame allocation concept on your main memory because your main memory is completely filled. Now you need to identify a victim page. So to identify victim page, there are many kinds of solutions are there. They are called as a page replacement algorithms in order to identify a victim page. Now here we are using a second policy when there are no empty slots. When there are no idle slots in your main memory, then you go for a concept called page replacement. Otherwise, go to the concept called frame allocation concept. Now come to the friends. So there are two important things. Page replacement can be done to identify a victim now. So what is identifying a victim? In the sense, the page replacement can be done in two varieties. One that I am replacing the page by using a dirty bit concept. If it is a 0, what to do? If it is a 1, what to do? These are the another two important points we want to learn. Observe carefully. Please see, your CPU is running a process by name called X, which consists of page number 1 and 2 and page number 3 and page number 4. Your main memory is being represented. There are some slots are there. This is your 0th slot, P1 is given. This is a frame 1 slot which is busy. This is a page 2. So page 2 is given. This is in the frame 3. Now it is a completely busy. And there is a one more slot is available. Please understand friends here. So when the CPU is performing execution, as we know that CPU is going to do line by line execution, that is nothing but sequential execution only. Please understand. Now I am taking a one more column into the active. That is the first one. What is the frame number of your requested page number? And we are going to see that whether it is a valid or invalid bit. And next one we are going to see the third bit is that is called dirty bit. The other name of a dirty bit is called as a modified bit only. It tells that whether the requested page or replacement page is modified or not. So please see that this is your per process page map table. Your page map table is allowed for every process. This page map table is for X. Now I am going to contact your page map table for automatic address binding. Now you see page number 0. I am keeping here, that is a frame number 4 and frame number 5. And now we are having the concept like this. This is given to your operating system, and we are having a one more slot. This is called idle. Now you see friends, so page number 0 is given. It is a valid because its a memory location are available to us. It is loaded here. Then the CPU comes to the execution of a P1. So P1 sees that. Please understand, page 1 is also available. It is also valid. Then it is available exactly here. Then control goes to the next instruction by the CPU. It is looking for P2. Yes, it is also valid because it is available there. I don't mind about the remaining bits. Please observe carefully. So whenever I am searching for page 3 and whenever I am searching for page 4, then the problem comes here. So page 3 is invalid as well as page 4 is also invalid. Then whenever they are invalid, we come to know that it is a page fault here, and the next page is also page fault here. Now whenever there is a page fault, the memory management unit of your operating system contact your secondary memory and try to swap in your page number 3 onto your main memory. But observe friends, your main memory, there is a one slot idle. So whenever one slot idle, immediately use the frame allocation concept. So therefore the page number 3 is a page fault that brought from your secondary memory, and it is placing exactly this particular place. Then whenever it is given, page number 3 is given a frame number 6 concept. Now therefore what happened? Update your page map table. This becomes valid only. Now the CPU goes to next page fault P4. Then the particular page has brought from your secondary memory and try to place it in main memory, but there are no idle slots here. Almost all entire memory is filled. Now you cannot use the frame allocation concept. You need to use the page replacement concept. So now you see page replacement concept in the sense, now I need to identify victim now. So who is going to be the victim? Whether P1 is a victim or P2 is a victim or P0 is a victim or P3 is a victim. In order to identify the victim, please understand, in order to identify the victim, we are going to use to identify victim. There is a need of what? Page replacement algorithms. In need of page replacement algorithm. But please understand friends, place replacement algorithms whenever you are doing, in order to increase your efficiency and decrease your page faults, the page replacement algorithms are being used. This place replacement algorithm meant for two purposes. One is to identify which particular page I need to replace, that is called a victim, and in order to what? A reduction of your number of page faults. So these are the two important goals of your particular page replacement algorithm. So in order to do, who is the victim, which page I need to brought it out from your secondary memory, that means main memory. So I need to do this time swap out operation. What is the swap out operation? All the pages, all the particular memory slots are being filled in your main memory. So some of the pages I need to bring back from your main memory to secondary memory. So I'm doing a what? There is a concept of a swap out I'm doing a swap out. Therefore, what is going to happen? That particular page is going to be eliminated, and so that the new page I can able to place into your main memory. That is a concept of what? Swapping. So to perform swapping, there is a requirement of what? Some of the page must be eliminated from your main memory. Therefore, you are going to get a free slot, and happily you can able to send the frame there. But is it compulsory to do swap out? This is the question mark. What is the meaning of swapping? What is the meaning of swap out? We know the meaning of swapping is nothing but place the particular page on your main memory. So when you are talking a swap in, this is your secondary memory, which consists a pool of pages here. So one of the page I'm going to place onto your main memory. This is what is the concept of what? In, swap in. So I'm doing a swap in. So what is the meaning of a swap out here? When you are using a concept of a swap out, some of the pages which are there, please understand, this is your main memory. So some of the pages which are there in your main memory are being brought back to your hard disk. What is the meaning of that? What is the meaning of swap out? The meaning of swap out is nothing but, please understand, saving the content. Please understand carefully, friends. What is the meaning of a swap out? I want to save the things whatever I modified in the particular file or particular frame. So in order to saving your content, the saving is not possible in main memory. Please understand, main memory is a temporary memory. So we want to save all our things in secondary storage devices, that is called your hard disk. Therefore, what is going to happen? I want to save it. So that's why what I am doing, bring that particular page, whatever page you are talking, please put it into your secondary memory only for the concept of what? Saving. If you not save, then what is going to happen? You are going to lose the content which is there in the particular page. Therefore, the meaning of a swap out is nothing but what? We are doing indirectly saving our content, whatever you did so far on your main memory, that is going to be saved into your secondary memory. If you not save, the content is going to be lost. Now our question is when to save, when not to save. This is important point. When to save and when not to save. For example, you see friends, I have opened a one file or one particular frame. Just I read it. So after reading, I am not doing any kind of operations right. Therefore, what happened? Simply I can close the particular file. You know MS Word you open. So I have opened a one particular file which are already existed. No content I added there. So simply I can able to close. It is not going to ask you want to save it or not. But see, after adding some content, at least one character also you add in your particular file, then if you unfortunately sudden close, then the system is going to ask you that you want to save it or not. Why? Because you performed those write operation temporarily, that is onto main memory. So we want to save it. Unless you save, you cannot able to sustain the data, new data. Therefore, what? When to save? When you modified the data, when you modified some content which are there in the particular file or which are there in the particular frame. When not to save? Just I opened the file only for read operation. I have not performed any write operation. Then therefore you can simply close it. So who is going to tell you this information? Whether you have modified your data or not, when to save, when not to save. This depends on your a new bit called what? Dirty bit. So this is also called as a modified bit. What this dirty bit is going to tell you, before doing a page replacement, you decide that whether your page is to be saved or not to be saved only because of what? Dirty bit only. If dirty bit is on, that means what? Some of the characters you are updated or added or created. Therefore, when the dirty bit is on, before you replace that page has to be saved. Otherwise, you cannot replace the page. So when dirty bit is off, then there is no concept of saving. I don't do any swap out there. Simply I can able to remove that. This is the difference between dirty bit on and dirty bit off. Please understand, friends. Swap out is not compulsory. Swap out is not compulsory. The swap out you can do only in the case of what dirty bit is on. When dirty bit is on, you know that some of the contents are modified. When dirty bit is off, just I open the file, no content is modified in that frame. Therefore, swap in is a mandatory, but swap out is not a mandatory. Why? Because that depends upon whether you modified or not. That is given by your dirty bit attribute. Therefore, friends, as per as previous diagram concerned, there is a one important bit called what? Dirty bit. This dirty bit will enable you whether you need to do swap out or not. Now you see, friends. Now see, please observe, swap out is nothing but whether the particular frame is available in main memory or not. Please, that is a what? Wrong approach. Please understand. Swap out means what? I am bringing the page from your main memory to secondary memory. It is not talking whether it is a hit or miss. Please understand. If the page is already available in your main memory, it is a page hit. So whenever you try to bring a particular page from your main memory to secondary memory, I'm doing a swap out. That means what? Whether to do swap out or not, that depends upon your dirty bit only. Please look at this example now. I'm saying there is a page map table. Please all of you understand. There is a page map table which is consists of 3 columns here. One column is the corresponding frame location, present or absent, modified bit. It is also called dirty bit only. There are some pages are there in your page map table. That is a page 0 and the location is a frame 1, and next page 1 and the location is a frame 2, and page 3 no location, that means it is absent. Please understand, friends, that means it is absent. That means your main memory is allocated only 2 slots for process X. You say that this is the process X page map table. Now what is going to happen? So your main memory consists of one page is allocated exactly in frame 1 slot. Your page 0 is loaded and frame 2 is allocated to page number 1. Now this is a completely busy if you are feeling. Now what is going to happen? This is absent. When this is absent, the CPU identifies that it is a page fault. When there is a page fault, it is also completely filled only. Now you see, I have a question to all of you. This is given to Y process. This is given to Y process. The P0 and P1 are belongs to process X only. All of you observe carefully. Now you tell me, these are given to process Y, this is also given to process Y. Now you observe, I want to execute page 3. You want to execute page 3 means the page 3 is not available, hence we want to do swap in now. So I am doing a swap in now. So before you want to do swap in, it checks that whether there are free slots are there or not. There are no free slots. Now I need to do what? Frame allocation cannot be done, but page replacement can be done. So which page I need to replace? Whether this particular PY space or PX pages. This is one of the important point. Which pages you are going to identify that they are victims? Process Y spaces or process X pages? So please chat with me, those who are online. So which pages you are going to identify as a victim? Is it a page process Y pages or process X pages or any of the process pages? So what is the correct? So which is the correct one? I want to identify a victim now as there are no free slots are available. Some of the old pages must be replaced with the new pages. So which page I can able to do? Process wise pages or process X pages. This is very important that don't disturb other processes. You need to disturb yourself only. So as you are running a process X, you need to concentrate about process X pages only. Therefore, either you can do this particular point or you can do this particular point. Now what I am going to do? Let us say I am disturbing P0. That means what? Page 0 I am disturbing. As you are doing a page 0 here, then what is going to happen? So before you do this page 0 out, before you want to delete this page 0 from your main memory, you need to decide that whether is it a modified or not. If I say that it is not modified, so I will say that dirty bit is off. When dirty bit is off, it may be also called as 0. When dirty bit is off, therefore I can easily eliminate that. Remove the page and just put your new page, that is called as what? P3. So your swapping is a success now. So you assume that one more page is also there, that is called page 4, and I do not have blank. That means what? Frame location, it is absent now. So now I need to replace to in order to perform in operation for this. So I'm doing in operation once again. I want to disturb my pages only, either page 3 or page 1. So I want to replace, for example, page 1. Before you want to remove this page 1 from your main memory, you need to see that your page 1 is modified or not. I will say this time 1. When you are saying this time 1, you cannot delete as you want. So what to do? There is a need of out operation now. So what I am doing? I am doing out operation now. Out operation means what? It just put that particular page back to your secondary memory. I want to save it. So which page you are saving? P1 is entered for saving. That means what? That page has brought back to your secondary memory. Now you can eliminate it because already it is entered into out operation successful. As out operation is successful, now I can able to place your new frame, that is called P4 into this. Friends, observe carefully. The main objective of page replacement algorithm is nothing but what? Identify victim and reduction of your page faults. The meaning of replacement is nothing but old page is eliminated, new page will be added. Before you eliminate, you need to see that whether your dirty bit is on or not. If your dirty bit is on, you need to have a swap out operation. If dirty bit is off, you need not require a swap out operation. Simply you can delete it. So these are the important things before you discuss about page replacement algorithms. Now that's what we discussed here. What is that? So what is that? If dirty bit is on, please understand. If dirty bit is on, which indicates that what? Old frame is modified with a new content. Old frame is modified with a new content. Hence, the old page must be swapped out. So swap in is always required, but swap out is not compulsory. Swap out is only compulsory when the dirty bit is a what? On. The other name of dirty bit is also called as modified bit. So if dirty bit is off, then there is no requirement of what? Swap out operation. Simply you can delete it. That's what. It indicates that old frame is not modified with any kind of a new content. Therefore, there is no requirement of what? Swap out. Please understand, friends. In second case, swap out is not required, only swap in is required. But in first case, there is a need of a swap in operation as well as there is a need of what? Swap out operation. Both operations are required. Now come to next point. So as I told you, the objective of page replacement algorithm increase the CPU efficiency by reduce the number of page faults. And it is also that identifying a victim in order to replace the page. There are two kinds of page replacement algorithms are there. One is a non-stack based. Non-stack based means there is a FIFO as well as there is a LIFO. Please understand. There is a FIFO as well as LIFO. Both are non-stack based. But stack based algorithms are optimal, LRU, MRU, LFU, and MFU2. So these are the different varieties of page replacement algorithms we have in real time in order to identify victim. Victim is nothing but which page I am going to place it, or which page I am going to remove from your main memory. That's what is the concept of page victim. Now you observe how you can able to generate a reference string. This is a very important. This is the agenda of today's class. So what is the meaning of this? So generation of a string is nothing but set of successively unique pages referred in the given list of virtual address or logical address. So it should be what? The consecutive duplicates must not be allowed. Only unique pages only are going to be allowed. But non-consecutive manner, you can see that duplicates are going to be allowed. For example, I say there are 100 words are there in your page, and the logical addresses are derived by your CPU is like this. Now he is telling you that identify the page numbers. Last session we learned how to identify the page numbers. Take one of your logical address, that is a 434, divided by your number of words, nothing but your page size, then you are going to get a 4 as your answer. So when you are talking a 4, this is your page number, friends. Observe carefully. This is how you can able to pull the pages from your logical address. Therefore, the first part are all page numbers only. Please understand. First part are all page numbers only. So the underlined one where I am saying they're all page numbers only. Now you know remaining is offset. How to get the offset? Take your particular logical address, perform a mod operation, write it reminder. Reminder is a 34. So your 34 is your D here, nothing but offset. So I'm not talking about offset now. I'm interested only in page numbers only. So you got the page numbers from first 4, next 4, next 4, next 3, next 4, next 3. As like this, there are huge number of page numbers have come. From there, we want to generate the reference string. How to generate the reference string? Remove immediate duplicates. That's it. This is the logic. Remove immediate duplicates which are occurring in the string. So first one I am writing. There are immediate duplicates are there. You cut them. Next one is 3. I am writing. Next one is a 4. That is not immediate duplicate. Please write it. And next one is 3. That is not immediate duplicate. 1 I am writing. And 7 I am writing. This 7 is a immediate duplicate. This 5 is immediate duplicates. So immediate duplicates are removed and the new sequence numbers we got. This is your page reference string. So this is, please understand now, this is your the concept of what 43431789765 is the concept of what your reference string. So after eliminating immediate duplicate page numbers, you got the reference string. So examiner will tell you this reference string only. So based on this reference string, we able to execute these algorithms. So one of the audience question that LIFO is not stack based. Observe one important careful information. What is that? When you are talking about a first in a first out, here priorities are dependent. Priorities are dependent. Please understand carefully. What is the meaning of priorities are dependent is page 0, page 1, page 2, page 3. 3 priority depends on 2, 2 priority depends on 1, and 1 priority depends on 0. This is what is the meaning. That means what? The next page, whenever you are saying that priority depends on its previous page. Now, as you are talking about the optimal, please understand this is another kind of algorithm. In optimal, the priorities are independent. What is the meaning of priorities are independent? Please observe carefully. So I don't know that the page is going to come because optimal is saying that longer duration. So the here what is going to happen? The priorities of the process may be what independent. Therefore, it is not the concept of what stack based. Whenever you say that priorities are independent, it is a concept called stack based only. So whenever priorities are dependent, that means what last number depends on before, before number depends on before, then it's called as what your next priority of the page is a concept called as what dependent, but here independent only. There are other algorithms like LRU and other algorithms like MRU and other algorithms like LFU. They're all what their priorities are what independent. But most of stack based, whenever you are calling, these are the two stack based algorithms, that is LRU and MRU, mainly exactly suitable to your stack based because the priorities are what independent, but you can consider that optimal is one of the case. And when you are talking about LIFO, please understand, so when you are talking about last in first out, so here what is going to happen? Last in first out means I say page 0 and page 1 and page 2. So I'm saying the page number 3. So this page number 3 priority, when you are talking this page number priority you are talking, then it is based on its previous only. So here also it is based on its previous only. Therefore, we are giving a chance that LIFO may comes under into non-stack based algorithm. Now come to, so first in first out. So when you are talking about the first in first out, we know the page which is entered is replaced. There is a very big drawback in this. What is that? Biladies anomaly. When you are talking about the Biladies anomaly, so if your allocated frames are increased, then phase faults are going to be increased. So we all know how to do it. So let me do. If you feel that I am doing it better, then use this logic. So the phase faults are increased as the number of allocated frames are increased. For example, you say that I am saying that there are 3 slots are available with me. Your main memory is having 3 slots. Now you see here, I may get some phase faults here. So phase faults are X now. If I am taking another memory with the slots 4 now, 1 and 2 and 3 and 4. So this is also our main memory. So here what is going to happen? Same reference string I am using, here as well as I am also using here. Then what is going to happen? Here your phase faults are increased. So that is the concept of what Biladies anomalies. There are 3 authors are there in this. They have identified that this kind of a logic in that Biladi is one of the author who is understand that if you are increasing the frame allocation capacity, then the phase faults are going to be increased. It is against the rules. Why it is against the rules? Because when you are allocating memory more, for example, you see what is the major, why the phase faults are coming? When memory is small, when memory is smaller, then there is a chance of phase fault. When you say that, when memory is a larger available, when memory is a larger available, then you say here what is going to happen? We want to see that the phase faults must be reduced. But if you are using the concept of a FIFO, this is against the rules. If you are increasing the number of frame slots, then it is also going to increase what? Phase faults too. So this is one of the question I'm taking with 3. So let us take so first 3 is inserted, then 2 is inserted, then 1 is inserted because your frame capacity is 3. Therefore, initially 3 slots are available. After inserting first slot, you are going to have 1 slot free. So let us do manual process like this. After that, we do a little bit speed. So there are 3 slots are available with you. I am allocating first 3 and the remaining slots are free for us. And this is busy. And now I am inserting 3 now. So it is a 3 2. And next one, it is an idle slot now. and now this is idle. Now I want to go for 1, so you can give it 3, 2, 1. Now your memory is completely filled now. So when your memory is completely filled, so up to first 3 steps. First step, this is the first step, and the second step and third step. Up to third step, I have used the first policy. What is the policy? Frame allocation policy. What is the frame allocation policy? I have requested 3, and the 3 is not available in your main memory. Please see that. The 3 is not available in main memory. Then it says that it is absent bit. When it is absent, then immediately we understand that it is a phase fault. So here, as it is absent, then it is a phase fault. Then the 2 I am trying to insert, the 2 is also not available in main memory because only 3 is available. Therefore, it is set to absent. Then we come to know that it is also phase fault. So as there is a free frame slot available with me, so I am allocating directly. I am not doing any phase replacement technique here. Then I am inserting a 1. It sees that 1 is not available here. Therefore, we understand that here its bits also kept as absent only. So 3, 2, 1. Now your memory is completely filled. You cannot use the frame allocation concept in the events of phase faults. Now I am inserting 0. When you are inserting 0, you need to identify the victim. As I am following a first in, first out concept, therefore what is going to happen? As 3 has come initially, so we are going to replace that. Therefore what is going to happen? Your 0 is also kept as a absent only, as the 0 is not available in this particular memory slot. So in place of 3, I am going to place what? 0 here. So 0 and 2 and 1. Then after that, I am referring next number, that is called 3. So 3 is also not available here, and it is also kept as absent. So now I need to replace that. So where to replace? After 3, the next number you have received is what? 2 now. So in place of 2, I can able to replace this 3. Therefore we are having a 0 and 3 and 1. Then I am seeing the 2. So this is how. This is a somewhat lengthy process. Instead of that, bit speed we will do like this. So I am saying first 3 is inserted, then 2 is inserted. Please observe how I am doing, and 1 is inserted. So up to this we understand that they are phase faults only. There are 3 phase faults. Next I am trying with 0. So exactly in place of 3 I can able to do this. This is replaced. Now you need to replace exactly 2 only. So I want to do with 3. So the 3 is not available in your main memory because recently it is modified with 0. So I have kept here 3. Then after that 2 I want to do. So 2 is removed just now. So 2 is also removed here. Now I want to insert 4. So 4 is going to be inserted here. And I want to insert 3. 3 is already hit. This is a hit now because already 3 is available in your particular main memory. So we are not going to disturb it. Next 2 I want to do. 2 is also available in main memory. This is going to be your hit. Now I want to insert 1. So next number is to be eliminated with the what? 3 only. So in this I am going to replace with the 1. And after that this is going to be 0. Then 0 is not available. So 0 is replaced. Next one to be replaced with the 4. 4 is already available. Then this is a hit. So this is how we understand that how to identify number of phase faults. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there are around 12 are there. In the 3 hits we identified, therefore number of phase faults are 9. The same example I am taking with allocation number 4. What will happen? So I am taking a allocation number 4 here. So as the allocation frame capacity is increased, is supposed to decrease the phase faults. Now let us see. So I have inserted 3, 2, 1, 0. Because 4 frames I can insert now. Because your memory has got a 4 blocks concept. So 3 inserted, 2 inserted, 1 inserted, 0 inserted. They are all your phase faults only. As 3 is not available, so 3 is inserted. This is set to F. As 2 is not available, it is a fault. As 1 is not available, it is a fault. As 0 is not available, it is a fault. 3 is available right now, so it is a hit. Please understand. and 2 is available, it is also hit. Please understand, 4 is not available, so the 4 I have replaced here. Then after that this becomes a fault. Now 3 is not available, therefore I am replacing here first in first out order, so therefore it is also fault. And 2 is not available, therefore it is also fault, that is replaced here. And after that 1 is not available, so 1 is also fault, so I am placing here. Then after that 0 is not available, next one to be eliminated this. Then after that 4 is not available, therefore next one is to be eliminated. So therefore you see friends, the finally you will see in your main memory, this is the order of the slots: page 0, page 4, page 2, page 1. So out of 12 there are only 2 hits and there are 10 misses. So what do we understand now? Your number of misses, that is nothing but miss ratio. Your miss ratio is 10 out of 12 references. Your hit ratio is 2 out of 12 references. So what do we understand? With the page frame size 3, your number of faults are 9. Please understand. And your page frame allocation I have increased to 4. It has to decrease, but it is not going to decrease. The page faults are increased. This is the concept of what is the situation of BLAD. So BLAD's anomaly is nothing but what? As you are increasing the number of allocated frames, then automatically page faults are going to be increased for the same string. So this problem can be eliminated using the concept of optimal page replacement, also called as a longest distance first in future references. Again I am telling you, longest distance first in future references. So what we are going to do here, we replace the page which is not referenced for a longer time. So what is the advantage? The advantage is that the page fault is very less as comparatively to all the algorithms. It also avoids the concept of what? BLAD's anomalies. What is the meaning of that? If I am saying that page frame size is equal to 3, then you are going to get some page faults here. So some number of page faults. If I am increasing the page allocated size to 4, then automatically your page faults are being decreased. So therefore you don't have the concept of what BLAD's anomalies in this. So how to do? Let us see. But what is the drawback in this? There is a drawback. You need to scan first. This is an important drawback. It takes some time complexity as comparatively to FIFO and LIFO algorithms. The FIFO and LIFO we know last in first out and first in first out, but here you need to see that which is the particular page is not referenced for a longer time. You need to do some scanning. That scanning takes some time, therefore it is a slower process than others. Apart from that, number of page faults are what? Reduced. Anyhow, it reduces the number of page faults, but it takes some time. It takes some time as comparatively to other algorithms. Now let us see. So here page reference string is given with allocated frame size is 3. Now I am doing 3 means what? First I have inserted 1. Then after this is a fault because the 1 is not available in your main memory. This is your main memory only. And 2 is also not available in main memory. Therefore it is a false. As there is a free slot available to me, so I am bringing that particular page. I am doing in operation. So I am using a frame allocation now. So 1 is a hit because 1 is already available in main memory. So we don't touch it. Now we want to go for 3. So 3 is not available in your main memory and it is a fault. Therefore 3 can be placed here using a frame allocation because I have got the sufficient slot. Now 7 I want to use. So 7 is not there in your main memory readily. Therefore it is a what? Fault now. So I want to replace it. So it is not possible because frame capacity is completed. Now I want to identify the victim. This time identify the victim is nothing but longer frame which is to be referenced. So let us see. So which is immediately referenced, which is not immediately referenced, that you need to understand. So now you see 1, 2, 3. So 1 is referencing and 3 is referencing and 2 is not there in the list. Therefore this is required and this is also required. So 3 is not required. So 2 is not required immediately. So what I am going to do? Exactly in this place 7 is got replaced. Now I want to replace, I want to use 4 now. So 4 is not available in your main memory. See the next immediate box, this box only. So 4 is not available in your main memory. Therefore it is a fault now. So which page we are going to replace? See that. So 1 is coming immediately and 3 is also coming immediately. 7 is not coming immediately. So in place of 7, I am using a 4 now. Then after that 5. So this 5 is not available in this box. Therefore it is also what? Fault now. So 3 is coming immediately and 1 is coming immediately and 4 is not coming immediately. Therefore in place of 4 I can able to replace this particular 5. Now after that I am checking about 6. 6 is also not available in this particular memory. Therefore 1 is coming immediately and 3 is coming immediately. So in place of 5 I have used 6. After that I am checking 3 is available and 1 is available, and I can say that this is a hit and this is the hit. Therefore friends, this is how you can able to use a concept of what? Optimal. You can test it by taking a page frame allocation. Page frame size is equal to 4. You check, you understand that your page faults are lesser than your page size is equal to 3. So what is the meaning of that, friends? If you are increasing the frame allocated capacity, then automatically what is going to happen? Your page faults are going to be decreased. Now let us go to LRU. So LRU is a reverse to your optimal. Please understand. Optimal is looking towards a forward direction and LRU means looking towards a backward direction. So please understand. I am looking a forward direction whether that page is immediately referencing or not immediately referencing. But LRU you need to look at in the fast. That means what? Longest distance first in fast references. So LRU is also very better algorithm. It also decreases your page faults when your page frames are allocated more. Now come to what the LRU is saying. So first one is a fault because one is not available. Your memory is idle now. Please understand, your memory is idle which do not have the page number 1. Therefore, as there are 3 slots are there with me, as your page frame size is 3. So 1 is inserted first. Then after that 2 is not there in your main memory. That is also fault. So 2 has been brought here. Next 1 is available in your main memory. Then it is considered as hit. Next 3 is not available in main memory and 3 is being placed here. So this is your fault. And 7 is not available in main memory and this is a fault. So now I want to do what? Victim. So who is going to be the victim? You see now, come to backward direction. What is the backward direction? 7 I want to use now. So 3 is immediately used. 1 is immediately used. Please understand. 2 is not immediately used. So immediately used is a 1 and 3 and 2 is not immediately used. So I'm going to use here the concept of what? 7 in this case. Okay. Next 4 I want to do. So 4 is not available in this. Therefore it is also what? Fault. Now therefore I am going to cross check. So 7 is immediately using and 3 is immediately using. So 1 is coming later. Therefore you please use 7 and 3 as it is. You replace 4 with that. Now 5 is not there in your list. It is also fault. Now you check in reverse order. 4 is immediately coming. Please drop it. And 7 is immediately coming. So 3 is coming later than that. So I can able to replace 5 in place of 3. Next 6 is not there with us. It is also fault. Now 5 is coming immediately. Please understand, 5 means most recent use, that is. And 4 is another next most recent use. 7 is coming later, which is the least recent used. Therefore in place of that you keep 6 now. Next 3 is also what? Fault. So 6 is used immediately and 5 is used immediately as they are most recently used, and 4 is not used. So 3 is being kept there. Then after that 1 is also fault here. Therefore, you see that 3 is immediately used, please drop it. 6 is immediately using, please drop it. 5 is the victim now, so that can be replaced with your 1. At last, you are having, these are the 3 frame numbers, that is nothing but 3 and 6 and 1. This is how about LRU. Now, what is LFU? So, LFU stands for least frequently used, also called as not frequently used. So, there are two important things here. It is maintaining now count variable. So, count variable is initially set to 0 and it is incremented by 1 at every reference or hit. So once you have removed the page, then what is going to happen? Your count value is set to reset. So these are the important things we want to identify. Initially your count value is 0 and it is incremented by 1 at every page hit or page reference. Then it is reset to 0 once after you are removing that particular page from your main memory. So we are going to take least frequently counted one in order to identify a victim now. So that's what it takes a page to replace which has got the least frequency count, which is nothing but that is going to be the victim which is having the least frequency count. So I'm doing once observe. So as far as LFU concerned, so there are 3 slots are there. In exam maximum he will give you 3 or 4 only. So first one is a fault. So 2 is inserted and the second one is also fault. Frames are available. Third one is also fault. Frames are available. Next 2 becomes what hit here. And why it is hit? Because already it is available in your main memory location. We are not going to touch it. Next 1. So when you are talking a 1 is not there in your main memory and it is a fault. So you need to look at the least frequently used algorithms in order to identify the victim. As I am using LFU, you need to maintain a count data structure here. So I am maintaining a count data structure. There are page number 1 is there, page number 2 is there, page number 3 is there, page number 4 is there, page number 5 is there, page number 7 is there. These are the page numbers are there 1, 2, 3, 4, 5, 7. Now I need to maintain a count. Initially the count value is 0 to all of the pages. Whenever it is being referenced, then its count becomes what? So initially their count is 0. Now see, whenever you reference the particular page, that means I have referenced 2. So the count of 2 becomes 1. I have referenced 3, the count of 3 becomes 1. I have referenced 4, the count of 4 is 1 now. Now after that, please observe, I have referenced 2 once again. So therefore the count of 2 is being incremented to 2. Now see friends, I want to go for now 1. When you are saying a 1, there is no space here. Therefore what is going to happen? You see the priorities now. So what is the priority here? This is not there with us and this count is a 1, this count is 1, this is not there with us, this is not there with us. 0 means that is not there with us. So now there are 3 frames which are in the race to be identified as a victim, that is a 2 and 3 and 4. Therefore what is going to happen? 2 count is more, we don't disturb, and 3 count is a 1 and 4 count is a 1. So whenever there is a tie, so there is a tie between your 3 and 4. Whenever there is a tie, your LFU is exactly very similar to before concept. That means it is uses the before in order to avoid the ties concept. Therefore what is going to happen? Before I am using now. So as the 3 appeared first than your 4, therefore in place of 3 I am going to use a what? 1 here. Now this is as it is I brought, this is as it is I brought. So once you say that the 3 is being removed from your particular memory, then your count is being reset to 0. Now therefore what happened? You got the new count 0 to 0 1 00. So recently one frame we brought, that is a what, 1. Therefore one count will be 1, 0 plus 1, because recently this has been brought. So this count is a 1. Now next number is a 3. So 3 is not there. Next number is a 3. That 3 is not there in this memory. Therefore what is going to happen? I need to identify the victim. So identify the victim is this count is a 1 and this count is a 1. Therefore again there is a tie between page number 4 and page number 1. So which page has come earlier? So 1 is very recently came, so I can able to remove your page number 4. So in place of 4 I am just placing a 3 here. So 2 1 3. Now when you are saying that 4 is been removed, then your count becomes what, 0 here. Now 3, the page number 3 has come, therefore your count becomes 1 here. Now I want to go for this time 7. So 7 is not there. So whenever 7 is not there, again we understand that there is a page fault here. When there is a page fault, there is a tie between 1 and 2 and 3. So 2 is almost all 2, I don't mind. Now least frequency count this one and this one. As 3 is very recently arrived, so I am able to change in where one particular position. So exactly this particular position 7 will come. This is as it is and this is as it is. Next 5 will come. When you are saying a 5, it is also fault. So please reset your count values now. So your count values very recently, 2 count is a 2 only, 7 count is a 1 now, and 3 count is also 1 now. Now I want to insert the next page. The next page is nothing but what? I am checking for 5. So again there is a tie between page number 3 and page number 7. As page number 7 is a very recently came and page number 3 is an older frame. Now in place of 3 I am going to place this particular 5. So therefore it is a 275 now. Then I want to go for, so when you have removed that particular page, so as I have removed your 3, page number 3, then it counts become 0 and fifth page number 5 count becomes 1. Now I want to go for page number 4. This is also fault as it is not available in this box. Therefore what is going to happen? Now 2 I am not going to disturb. So there is a tie between page number 5 and page number 7 in the frequency. Therefore the very recent page is a 5. So in place of 7 we are going to do this elimination. The victim is a 7 now. So 4 is there and 5 is there. Then after that your count is becomes once again the 7 count becomes 0 now as it is removed. Now 3 I want to insert. Now in place of that, please see there is a tie between 4 and 5. Then in place of 5 I can able to do this frame number 3. Then it is 243. This is how about LFU. So please understand friends, one important thing I want to tell you. What is that? There are some opponent algorithms are there. When you are talking FIFO, the opposite algorithm is LIFO. LIFO is a very recently given question. Please understand. And when you are talking about stack-based algorithm LRU, then there is an opposite called MRU, most recent used. And there is a least frequently used. And there is opposite algorithm most frequently used. Apart from that, there is a one algorithm which is completely different from that. That is called as a what? Optimality. So among all the algorithms, this is the best algorithm as it is going to give you what? Very less number of page faults. This is a very important algorithm for us. Now we will discuss one important question. Please understand this question carefully. So least frequently used is asking us to use, but the very important point is this. What he is telling? If at all there are some ties, in LFU we have used FIFO, but he is saying that use LRU technique. Please understand carefully. use a LRU technique in order to break the ties. Then he is asking, during the program execution, how many times the pages 1, 2, 3, 4 are brought to the memory? This is a very important previously given question. So now let us see. So as he is telling that LFU, now I need to follow the count data structure here. I am taking the count. There are 4 unique pages. 1, 2, 3, 4. Initially the count values are zeros as we know. Count is 0. Now the page allocated size is 3. So take 3 rows now. 1, 2 and 3. I am inserting 1. Why I am inserting 1? Because it is a fault. Please understand. Because 1 is not available. So next I am inserting 3. Because 3 is not available, it is also fault. Please understand carefully. Next I am using a 1. It is a hit. So I am not mind. Next I want to insert 3. It is also available as it is a hit. Now I am using a 4. So 4 is not there and it is a fault. Please understand. So there is a frame capacity is there, allocated memory is there. Therefore I can able to insert that 4 here. I am using a frame allocation concept now. So now I want to insert 2. Please understand. 2 is not there. So far I want to tell you one important thing. Page number 1, one time brought. And page number 3, one time brought. Brought means what? Bring from your secondary memory and place it onto main memory. That's what the meaning of brought. Please understand. How many times the page has brought to the memory means from secondary memory. And next one, page number 4. It also brought only one time so far. Now I am talking about 2. So 2 is not there here. Now let us increment the count. 1 count is a 1 and 3 count is a 1 and 4 count is a 1. Understand friends carefully. Now I want to insert 4. When you want to insert a 4, 4 is a fault. So we want to insert 2. So as 2 is a fault now. So we want to identify the victim now. So victim means I am using LFU concept to identify the victim. So all the counts are same. When all the counts are same, we have to use the by default FIFO mechanism. But he said that to use what? LRU mechanism. Please understand. So I have to use LRU. LRU means what? Longest never used in the fast references. So going back, I am saying. Right now I am here only. So I am going back. 4 is immediately used. Most recent use. 4 is immediately used means most recent used. 3 is immediately used. Next most recent used. And 1 is a later used. Therefore, I can able to identify victim as a 1 and 2 is being placed here. Now you see 2 also brought only one time only from the secondary memory to main memory. Next 2 is hit. So we don't mind. Next 4 I want to bring. When you want to bring 4, please understand. So when you want to bring 4, so what to do? So the 4 is already available here. So 2 and 3 and 4, it's already available. Now you tell me friends, this is a what? Hit now. Now you tell me how many times they are being brought into main memory. So as far as that, you please understand one important thing. So as you have replaced 1, please understand, as you have replaced 1, so 1 count becomes 0 and 2 count, please understand carefully, and 2 count becomes 1. So when you are saying this is a 2 and this count is going to be increased to 1. If you are doing like this, there may be a chance of what? Some error. So we want to do in a good manner like this. Now again, I am taking this time 1 here and 2 here and 3 here, 4 here. And initially count is a 0 to all of them. Now I have inserted 1 here and 3 here. and 1 and 3. That means what? The count of 1 initially 1 and count of 3 initially 1 and 1 is a hit here. So the count of 1 is a 2 now. Please understand. Now 3 is also hit now. So 3 count is also become 2 now. Now I am inserting a 4. 4 is not there, but there is a frame allocation. Now it is a 1. Now your count is like this. Now you see, I want to go for now 2. When you are trying to insert 2, the count of this is 2 and the count of this is 2. So therefore, it is satisfied because 1 is the least count now. I am not going to use any kind of LRU algorithm because of what? That is only the having the least count. Therefore, in place of 4, just I kept 2 and 1 and 3. Therefore, the count is this is a 2 and this is a 2 and this is a 1 and this is a 0. And now after that, one more time I am referencing 2 now. So the count becomes 2 here. So I want to bring it 4 once again. So now you have to use the concept of what? LRU. So LRU means what? I want to insert 4 means 2 is using immediately. Then after that, the longest back, then 3 is using immediately. So I can able to place 4. So 4 has been brought from your secondary memory 2 times. So therefore, if you are accepting your count properly, then you are going to get exactly answer. Otherwise, your answer is going to be fall into option C. So this is about your textbook regular example. So I am using P4. This is our last example. So as we are using a P4, so 7, 0, 1, they are your phase faults. So now I want to use 2 now. So 2 can be replaced here. Next 0 is a hit now. Next after that 3 is not there with us. So if you are having a confusion, then I will tell you another method for FIFO using the concept of what delimiter. In FIFO we are not going to consider hits. We are only considering what? Faults only. If you are having a confusion with the FIFO, then I am going to give you another kind of a methodology. Please understand that. So what is that? First 7, this is the delimiter, and next one is 0, next one is 1. Now this is a fault and this is a fault, this is a fault. Now I want to insert 2. When you want to insert 2, 7 is marked as a delimiter, so in that place it is going to be replaced. Next 0, delimiter is increased. Now 1. Now I want to insert next 0 here. So this is a fault. I want to insert 0 now. So 0 is a hit. Therefore what is going to happen? 2 here, 0 here, 1 here. Your delimiter is not going to be changed in the event of what? Hits. Now I want to go for next 3. So 3 is a fault now. As 3 is a fault, now you see the delimiter is marked here. So I am inserting a 3. So 2, 3, 1. Now marker is incremented. Now after that we want to go for 0. 0 is also fault. Therefore this is a marked here. Then it is a 2, 3, 0. Your marker is incremented. This is now. Next 4 is also your fault. Now I can able to do 4, 3, 0 and marker is incremented. This is after inserting 4. Then I want to insert 2. 2 is also fault. Now 2 can be replaced here. It becomes 4 to 0 after inserting 2. So your victim marker is incremented now. So I want to implement 3 now. So 3 is also what? Fault here. So therefore it is a 4 to 3. Your victim marker is incremented. Next I want to go for now 0. So 0 is also going to be a fault. It is a 0 to 3 and victim marker is incremented. Next 3 is a hit here and next 2 is also hit here. And next we want to go for 1, that is a fall. So now after inserting a 1 here, it is a 0, 1, 3 and victim marker is incremented. Now I want to go for insertion of 2. Please understand. When you are inserting of 2, your marker is identified there. Then it becomes what? 0, 1, 2. Then after that, I want to insert 0. So 0 is going to be hit now. You can drop it as it is. And after that, that means what? Your 0 is going to be the next victim marker. So 0 is already available. Therefore 0, 1, 2. Victim marker is not going to be changed. 1 is also hit to you. So victim marker is not changed. So 0 only. Then 1 and 2. Then after that is 7. So this is your victim marker. So 1 and 2. Next 0 is also fault and your victim marker is incremented. It is a 7, 0 and victim marker is incremented. Next I want to insert 1. So now it is a what? 7, 0, 1. So this is one of the beautiful technique. Just how to increase your markers. Nothing but what? Identifying victims. This methodology is very easy. The only one thing is that hits we don't consider. Hits, the marker will be staying there only, but only in the events of what replacement the marker is going to be what? Changed. In the same way, you can also do what? Optimal. You can also do what? LRU. If I am doing optimal, so if I am doing optimal case, optimal is nothing but what? The longest used in a future references. So as usually 701. I want to go for 2 now. So 2 means what? Immediately, please see that immediately 0 we are using. Then immediately 1 we are using. So 7 can be replaced. So I got 2 now. Now I want to go for 0. It is a hit. We don't discuss. And 3 we want to see. So immediately 0 is coming. And immediately 2 is coming. So 1 is coming later that. So you please give. Why we are sustaining them? To identify hits. The main concept of optimality is nothing but we are keeping the immediate number. That means what? We are getting immediate next. That is the concept. So 2, 0 we are keeping here. So as we are inserting 3, so 3 can be replaced in this. Now after that, we want to go for 0 now. So 0 is a hit. So 203. This is the idea of optimality. Then 4. 4 in the sense immediate one we want to keep. Immediate one means what? 2 is immediate, 3 is immediate. In place of this you can able to do this. Next 2, 3. 2 is a hit and 3 is also hit. We don't do. Next 0. When you are doing 0, 2 is immediately coming, 3 is immediately coming in the future references. So 2 and 3, just you place 0 over there. Then after that 3 is a hit to us and 2 is also hit to us. This is how hits are increasing. And 1 you want to insert mean this is the fault to you. So 2 is immediately available, 0 is immediately available and 3 is not there. Therefore this is the victim. Next 2 becomes a what? Hit here and 0 is also hit here. 1 is also what? Hit here. Now we want to go for what? 701. So 701 means 0 is coming immediately, 1 is coming immediately. So in place of that, I can keep what? 7. So this is about optimality. So last one we are executing before closing the session, that is LRU. What the LRU? It is opposite to your optimal. We are going to look at the longest one in a fast references. So your LRU, when are you talking about your LRU? So as usually 701, they are the false to us. And 2 I want to insert. 2 you want to insert in the sense, look at the fast references side. So 1 is coming immediately, 0 is immediately used. That is means most recent use. 7 is not used. So therefore 7 is the victim now. 201. Next 0 is going to be the hit to us. Next, 3 is not there. So you want to identify 3 means identify the victim now. So fast references, 0 is coming immediately, and after that, please understand, 0 is already used immediately and 2 is immediately used. So 1 is a least recent used. So in place of that, 3 can be replaced. Then after that, 0 is going to be the hit to that, and 4 you want to use. So 0 very most recent used, 3 is a most recent used, and 4 can be replaced there. Then after that, 2 I want to use. So 2 means 4 immediately used and 0 immediately used. Therefore, what is going to happen? You please drop them, 4 and 0 immediately used. So in place of 3, just I have used 2. Next, 3 I want. 3 you want in the sense 2 and 4 are there immediately. So in place of this, you have used 3. Then after that, 0 and 3. So 0 means what? So 3 is immediately recent, most recent use. 2 is a most recent use. But drop them. So in place of 4, just you keep 0. Then after that, it is going to be the hit, and 2 is going to be the hit now. Now we are going to concentrate about 1. 1 means look at the other side, fast side only. So 3 is immediately used, 2 is immediately used, so 1 is the longer used. Then I want to go for 2. This is going to be the hit. We want to go for 0. When you are going for 0, 2 is immediately used, most recent used, 1 is most recent used, so 0 can be replaced here. Then after that 1, so 1 is going to be the hit now. So 7 is going to be the fault. So 1 is the most recent used and 2 is the least recent used. Therefore 7 I am going to keep. It's a 107. Next, this is going to be the hit. This is going to be. This is how, friends. So LRU is opposite to your optimal or opposite to your MRU2. So therefore, so this is how you are going to see that page replacement algorithms. You need to concentrate mainly, like FIFO is the most one of the important example, and LRU is another very important example, and optimal is another very important example. Remaining, he may or he may not ask, but very recently he put the question on LIFO also. So, but these are the three very important place replacement algorithms. So in that, the best algorithm is a what? Optimal only. LRU we do fast references, optimal we do future references. MRU also we look at into fast references only, which is the most recent use. So well, friends, so we'll meet in the next session. So next session, tomorrow we are going to meet on YouTube. That is at 2 p.m. We are going to discuss about TLB and multi-level paging. This is a very important concept. So we discuss tomorrow TLB and multi-level paging. So in theory part, the page replacement algorithm we are not going to get in theory part. It is a completely problematic. If you want to ask in theory part, he will ask that which is the better algorithm, or if FIFO is suffering from Biladi. Biladi question he given like 4-5 times only. So which is going to give? Optimal is going to give less number of page faults, and by increasing the page allocation capacity, then you say that we are going to see that number of page faults are going to be decreased. So today there is no special class. So tomorrow we are going to discuss 2 p.m. TLB and multi-level paging, and tomorrow 7 p.m. we are having a questionnaire on this kind of page replacement algorithms. So we meet tomorrow 2 p.m. and tomorrow 7 p.m. there is a class, a special class on page replacement algorithms. Once you do the page replacement algorithms, there are very good questions are there. Typical questions are there in page replacement algorithms. Don't miss tomorrow's special class 7 p.m. and tomorrow 2 p.m. TLB. Especially need to learn multi-level paging. Very important area. TLB and multi-level paging. Okay, friends. So we'll meet in tomorrow's session. Thank you very much.